Hi folks, I'm here going to do a screencast on algebraic simplifying and finding derivatives. So the first one we're going to do is an algebraic skill called dividing out, and what this is it's a skill that you can use. And actually, let me show you this. If you have 2 plus 6 and divide by 2, that's the same thing as 2 plus 6 is 8 divided by 2 is 4, but we can do it a different way. We can also divide things out separately. And so you can go 2 divided by 2 plus 6 divided by 2, which happens to be 1 plus 3, which is 4. So we can divide things out this way. I call this another one of the heart diagrams. So you divide things out separately that way. Let's take a look and see what we can do here similarly. Well, that has an exponent 1 on it. So let's see if I can divide this out. So simplify first, then differentiate. So what we end up with is x squared over x to the 1 plus 3 over x to the 1, which ends up being, oh, what rule do I use here? That's right, exponent rules. So it just becomes x plus 3x to the minus 1. And that's what y equals. Now I can actually differentiate. So I'm going to take this right here, go up to here, and differentiate. Y prime equals, the derivative of x is just 1, and the derivative of 3x to the minus 1 is going to be, so plus negative 1, because that negative 1 becomes the coefficient, multiplied by the other coefficient 3, reduce the exponent by 1, negative 2. So that will become 1 minus 3 over x squared. And that's what y prime is. Okay, folks, so again, that dividing out is critical. And you might want to take these examples down. You can certainly pause and rewind. There's lots of different options. Okay. We can also use exponent rules to simplify. So if we had this function here, 1 over 3x times root x. Well, I've got to take that and simplify it algebraically first. So that's 1 over 3x multiplied by x to the 1/2. Well, 3x times x to the 1/2, I need to put an exponent of 1 there. So that's going to be 1 over 3 x to the 1 plus 1/2, which will equal 1 over 3x to the 3 over 2. And that's what f at x equals. So I've converted the radical to rational exponents, and I have multiplied the terms together, so I had to add the exponents. So now let's rewrite these in the numerator. So that is, since it's in the bottom, it's showing repeated division. We need to write it as a negative exponent in the numerator before we differentiate. So it's 1/3 x to the negative 3 over 2. And now we differentiate. F prime of x equals, bring that to the front, negative 3 over 2, multiplied by the original coefficient of 1/3, x to the negative 3 over 2 minus 2 over 2, because I have to minus 1. Divide out the 3's, so it becomes negative 1/2 x to the negative 5 over 2. Now I can rewrite this with radicals. So a negative means it's going to appear in the bottom. The 5 is the exponent, the 2 is the root. Negative 1 over 2 root of x to the 5th. And that is the derivative. Okay, now we need to be doing some expanding. So this says 10 pi multiplied by x plus 4. So we can multiply that through, expanding through brackets. So it's going to be 10 pi x plus 4 times 10 is 40 pi. So expand first, then differentiate. Well, the derivative of that is just a constant, or that is just a constant. That's just 40 times a number, and the derivative of any number is 0. The derivative of a constant is 0. And then I need to get the derivative of 10 times pi times x. Well, what's the slope of 10 pi x? It's just 10 pi. Okay, so y prime is 10 pi. But again, I had to expand through the brackets first, then apply the power rule. Okay, and here's our last one with expansion. So this you might have used FOIL. There's a lot of different ways you can do this. The double distributive law. But whenever you see something like this, we don't have a rule for that yet to differentiate it. There is a rule, it's called the product rule, but we don't know that yet, so we need to expand through brackets. By the way, d by dx means I have to differentiate, and I haven't done it yet. So expanding through this bracket, I'm going to have 2x times x, 2x times 4, 3 times x, 3 times minus 4. 2x squared minus 5x minus 12. And now it's in a form that we can apply the power rule of derivatives. The derivative of 2x squared, or the slope of 2x squared, is 4x. The derivative of minus 5x is minus 5. And the derivative of 12 is 0. So the derivative is just 4x minus 5. Okay, folks, so I've gone through 3 algebraic strategies for simplifying first. The first one is dividing out. The second one was applying exponent rules to simplify. And the third one's expanding through brackets. Okay, hopefully you're okay with that and have some success with your work. Have a good day and night.